Hi there. I'd like to take a few minutes and talk about the empirical rule. It turns out that if you have a normal model or data that's essentially in the shape of a bell curve, that about 68% of those values will fall within one standard deviation of the mean. 95% of the values will fall within two standard deviations of the mean, and finally, 99.7, practically all, of the values will fall within three standard deviations of the mean. So let's go back to the pine trees that we've had previously in this lesson, and let me give you a little bit more information about them. The trunks of pine trees are normally distributed with a mean of 2 feet and a standard deviation of 0.37 feet. So as I read this, when I see normally distributed, I'm automatically thinking the bell curve. So I have one here. At the top, I placed our mean of 2 feet and our standard deviation is 0.37 feet, as stated on the previous slide. Now I'm going to take a moment to label this curve. If you notice, I have a mark right under the peak of this, which will indicate the mean, and three equally spaced tick marks to the right and to the left. So our mean of 2 feet will go under the middle. And then as I march out to the right, I'm going to add a standard deviation every time. If I add it again, I'll get 2.74 for the second tick mark. If I add it a third time for the third tick mark, or three standard deviations to the right, I get and arrive at 3.11 feet. Now I'm going to do the same thing to the left, except I'm going to subtract 0.37. So 1.63 is my first tick mark to the left. Two standard deviations to the left, I'll have 1.26. And finally, if I subtract it one more time, I'll arrive at 0.89 feet. So I have my horizontal axis of this model clearly labeled with the mean and the standard deviations. The next thing to do to show you the empirical rule is to talk about these percentages we were given. So I was told that if I go in one standard deviation of the mean, that is to the right or the left, that would be 68% of the data. That's the first thing we learned about the empirical rule. So I have 68% of the data I would collect would fall in this region here, the largest region here in the middle. Now, since I have this here and I'm going to build on it, I'm going to divide this region into two equal pieces. So if I slice it down the middle at the mean, that means I would have 34% on each side. Just split the 68% evenly to the left and to the right. Now, I want to fill this out and label this model using the empirical rule statements. So if I go out one more standard deviation, you see these lines flying up here. Now I'm two standard deviations from the mean at 1.26 feet and 2.74 feet. I've essentially, according to the empirical rule, that's 95% of my data. So how much did I gain by going out an extra standard deviation? Well, if you look at the arithmetic here, I gained 27% more, or 27 percentage points. Now, I did that by going to the right and the left. So I have to divide that, split it into two pieces. So essentially, I gained 13.5% in either direction. Finally, I guess not finally, I have a couple more of these. If I go three standard deviations to the left and to the right, the empirical rule tells me that's 99.7% of the data. And again, I went from 95 to 99.7 by going one more standard deviation, and that together is 4.7% I gained. I'm going to split that into two equal pieces, which means that these smaller, sort of almost triangular looking regions on the left and the right both have 2.35% of data in it. Now I want to be completely thorough with this, and I want to say, what if we went out as many standard deviations as we can imagine and pick up that little extra percentage? So if I went as far as I can imagine, theoretically I'd pick up 100% of my data, which means beyond the third standard deviation, I've gained only 0.3%. Again, splitting it in two equal pieces, That means that in each of these small little tails here, I've gained 0.15%. Now, you don't have to go through this process every time you use the empirical rule. I like to do it as a teacher so you understand where these numbers and percents are coming from. You are allowed just to simply memorize these four numbers: 34%, 13.5%, 2.35%, and 0.15%. If you notice, the largest number, 34%, goes in the largest region. The next largest number goes in the next largest region, and so forth. And if you look to the left, this is just a mirror image of what you see on the right. So it's pretty easy numbers to put in. And now we can use the empirical rule to answer questions. So what percent of pine trees have trunks between 1.26 feet and 2.74 feet? So let's see, let's find that along our axis. Here's 1.26 in red and 2.74 in red, so I've highlighted them there. To figure out that percent, I need to see the percents that are in between the two. So now I have 13.5, 34%, and another 13.5. If I add those together, that is 95%. 95% of pine trees would have a trunk circumference between these two measures, 1.26 feet and 2.74 feet. And that makes sense because, I said if you go 2 standard deviations, there to the right and then there to the left, that should be 95% of your data. Let's try another. What percent of pine trees have a trunk circumference less than 1.63 feet? I've gone ahead and found 1.63 feet on the horizontal axis. So drew a red line there to help my eyes focus. And if I say less than 1.63 feet, we're considering these percentages that are to the left of 1.63 feet. If we add these percentages together, we arrive at 16%. So 16% of pine trees will have trunk circumferences less than 1.63 feet. Finally, last one, 68% of pine trees have a trunk circumference between blank and blank. Now, what's different about this problem is I've given you a percentage and I'm seeking out a measurement, the trunk circumference measurements. Whereas in the first two problems, I gave you measurements of trunk circumferences and was seeking percentages as answers. So that 68% hopefully should ring a bell. There's only one way we can grab these percentages that we know right now in this rule and make a 68%, and that would be the middle two. We combine them together. That means that 1.63 and 2.37, these two measurements would trap the middle 68% of pine trees. So the answer to this question is 1.63 feet and 2.37 feet. I hope this helps you get your bearings and understand the empirical rule a little bit better.